Ladies and gentlemen, welcome back to our help videos over the Test Premier 8-20, Part 1, 25 objective questions. This is our fifth video over these 25 questions. Our last video, we got all the way through number 14 up to letter E. We already know that the correct answer to number 14 is B. The oxidation number of arsenic As3- is 0. It can't be. That would be false. It can't be 3. If the monoatomic ion is 3-, the oxidation number has to be -3. Remember, oxidation numbers will always equal the charge of the ion. How do we tell the difference between an actual charge, 3-, and an oxidation number, -3? Charges are written number followed by the charge. Oxidation numbers are written sign followed by the number. But letter E, why is letter E true? Well, in this ion, this isn't one of the polys we had to know, but in this ion right here, oxygen gets its number. It has the higher electronegativity, so it gets its -2. Oxygen's 4 of them there, so the total minus is -8. This poly adds up to 2-. If the poly's charge is 2-, then the oxidation numbers must add up to -2. So if the oxygen's total is -8, MO must be +6. We have one MO, molybdenum here, so it has to be +6. True, it is +6. All right, now 15, 16, 17, 18. Or actually 15, 16, 17. We're dealing with this reaction right here. Use the reaction below to answer the following. Here we have manganese 4 oxide reacting with hydrochloric acid, and when we're done, we have manganese 2 chloride, chlorine gas, and water. First question they're asking is what substance is reduced? Reduced. If you remember, oil rig, reduced, RIG. Reduced is gain in electrons or gain in control of electrons. Rig, RIG, gain in control. So that means if you're reduced, your oxidation number must go down. So let's find out whose oxidation number is going down. Here, manganese's oxidation number is +4. Oxygen gets its -2. This is not the peroxide ion here. The peroxide ion is usually with the alkali metals. Manganese is a transition metal. So we've got MnO2. Oxygen gets its -2 for a total of -4. So the manganese must be +4, and we only have one of them at +4. One of them adds up to +4, so it must be +4. So manganese is +4 over on the left side. On the right side, manganese is now with chlorides. Chlorine's the third strongest. It gets its -1. We've got 2 chlorides at -1 for a total of -2. So the manganeses must add up to +2. We have one manganese adding up to +2, so its individual charge is +2. So manganese went from +4 down to +2. Manganese essentially was reduced. Its number was reduced or lowered from +4 to +2. So what substance is reduced? Number 15, manganese is reduced, letter A. Number 16, what substance is the oxidizing agent? The oxidizing agent contains the substance that was reduced. The oxidizing agent contains the substance that was reduced, because in order for you to be reduced, you have to oxidize something else. So we're looking for the substance that contains the thing that was reduced. Letter 15, they're asking who was reduced. It was manganese. What's the substance that contained the manganese? MnO2. Letter E, manganese 4 oxide. Sometimes called manganese dioxide, manganese 4 oxide. is the oxidizing agent. Number 17, what substance is oxidized in the reaction above? If you remember oxidized, oil rig. If you are oxidized, oxidation is loss of electrons or loss of control. If you lose control of negative things, if you're taking away negative things, your number is going to go up, more positive. Losing something negative is going to leave you more positive than you were before. So we're looking for something whose number increased. Reduction, your oxidation number decreases. Let's take a look. Chlorine right here is with the hydrogen. Its oxidation number is going to be -1. Chlorine's electronegativity is 3O. It's the third strongest. Hydrogen's written in the front, so the thing on the right gets its number. It's -1. Over here, chlorine is with other chlorines. So it goes, when an element is by itself or with itself, its number is automatically 0. An element's oxidation number is automatically 0. You cannot control or hog electrons from yourself. So chlorine goes from -1 up to 0. Its number went up. It lost control of electrons. Here it was controlling electrons. Here it's not controlling electrons. It lost control of electrons. Oil, oxidation is loss. Oil, oxidation is loss of control. It went from -1 up to 0. Now you might say, oh my gosh, no, the chlorines here, though, these chlorines are still -1. They didn't change. Oh, I agree. Not all of them changed, but some of them changed. Some of the chlorines were oxidized. Number 17, Cl. If they asked us what the reducing agent was, and they didn't, what is the reducing agent? Well, the reducing agent contains the substance that was oxidized. Here, chloride was oxidized into chlorine. So HCl would be the reducing agent. HCl would be the reducing agent. All right, that's 15 and 16. And 17, and the rest of number 14. We have time to go on and take a look at 18. Number 18, which one of the statements is false concerning this reaction right here? What statements are false? Statement A, the reaction single, displacement, or replacement. In single, we have an element replacing another element in a compound. Metals would replace another metal. So if this is single, copper should replace silver. It did. Over here, the copper's now with the nitrate. Silver was knocked out, displaced, or replaced in the compound. That is a single. Letter B is copper oxidized. An element by itself is always 0. Copper went from 0 to +1 because the nitrate ion is one of our polys. It's 1-, so its oxidation number is -1 overall. That means the copper's +1. So copper went from 0 up to +1. Oxidized, if you remember, oil, oxidation is loss of control of negative things. So copper went from 0 up to +1. It lost control of one of its electrons. Where did that electron go? It actually went to silver. Copper forced that electron onto the silver. So the copper was oxidized. It went up from 0 to +1. Here it says letter C, silver's reduced. Well, silver started out as +1. Nitrate's -1. Over here, silver is now by itself. So silver went from +1 down to, its number was +1, and it was reduced or lowered to 0. So silver was reduced. Its number went down. Remember, reduction is rig, not frig. Rig. Silver is reduced. Rig stands for reduction is gaining control. Silver has +1. It gained control of an electron, which put it down to 0. Silver is reduced. If silver was reduced, that means something else was oxidized. That would mean that silver nitrate, since silver was reduced, it is the oxidizing agent. not the reducing agent. The reducing agent contains the substance that was oxidized. The oxidizing agent contains the substance that was reduced. So silver nitrate here is an oxidizing agent, not a reducing agent. Let's see if we have a chance to get through number 19. Which of the following substance or compounds is incorrectly written in the stock name? Let's take a look at SF6 first. Fluorides or fluorine's going to get its number here. It's the strongest electronegativity of all. Its number is -1. It's a halogen, family Roman 7, group 17. They need 1 electron to get 18. We've got 6 fluorines here, all at -1. So the total minus is -6. That means the total plus would have to be +6 because this does not have a compound. SF6, the sulfur, is +6. What would be the prefix name for this SF6? It would be sulfur hexafluoride. In the prefix system, it's sulfur hexafluoride. In the stock system, we use a Roman numeral. The Roman numeral is equal to the oxidation number of the less electronegative element, in this case sulfur, sulfur 6. This compound right here, we could call this dinitrogen tetroxide using prefixes, dinitrogen tetroxide. The stock system, though, does not use prefixes. So we have to figure out what nitrogen's oxidation number here is. Oxygen is the second strongest electronegativity at 3,5. It gets its number of -2. We've got 4 at -2 for a total of -8. Overall, the compound is 0, so the pluses would have to be 8 plus 8 minus 8 is 0. We've got 2 nitrogens adding up to +8, so each of them would be +4. That would be nitrogen 4. That one's true. Letter C, what do we got here in letter C? This could be called selenium tetrachloride. It could also be called stock system, where we use a Roman numeral. Chloride's third highest electronegativity. The chlorides would have a -1. We have 4 chlorides at -1 for a total of -4. Overall, there's no charge, so the seleniums would have to add up to +4. We have 1 selenium adding up to +4, so each of the seleniums is +4. That would indeed be selenium 4 chloride. Let's take a look at letter AB. I don't know why we're going this direction. Letter AB. We could call this diarsenic trisulfide. That's the prefix system. But they want to know the stock system. Sulfide gets its -2. Or sulfurs get its -2. 3 times -2 is -6. Overall, there is no charge in this compound. So what do I add to -6 to get 0? That's a +6. I have 2 arsenics adding up to +6. Each arsenic must be +3. That would be arsenic 3. In the stock system, you use a Roman numeral to tell you the oxidation number. Here we have titanium sulfate compound, but we want to know what titanium's oxidation number is here so we can write it in stock system. The sulfate ion is -2, so its oxidation number must add up to -2. What do I have to add to -2 to have an overall neutral charge? That's +2. We have 1 titanium that must be +2, so its oxidation number is +2, titanium 2 sulfate. Well, all of those are true, so this one's false. Why is that? Is this the peroxide ion? Well, first of all, the peroxide ion is almost never with the transition metal. It's with alkali metals. It can't be the peroxide ion. How do I know that? Well, let's start adding it up. Would it be manganese 2 peroxide anyway? Well, let's find it out. If this isn't the peroxide ion, each of those oxygens is -2 for a total of -4. So the total positives would have to be +4 since overall there's no charge. So it would be manganese 4 oxide, not manganese 2 peroxide. Remember, the peroxide ion is not with the transition metals, it's with the alkali metals. Thank you for watching Help Video number 5.